Hello and welcome all to yet another video lecture on our lecture series on design of multi-story RCC office building based on the Nepal National Building Code. In our previous lecture, we discussed on some post-analysis checks to be performed in ETABS, and today we will be seeing the design of our structure. And in today's lesson, we will be looking at the design of beams, columns, and shear walls in particular. So before going through the design process, here I have made a few changes in our model. First, what I have done is, if we go to the plan view in any floor, you can see that I have modeled secondary beams here. These beams along this grid 1, 2, 3, 4, 5 and A, B, C, D, these are our main beams. Whereas these beams in the middle here, if you see, these are our secondary beams. And we have drawn secondary beams along both x and y axis. So what I did to draw the secondary beams was, first I defined a different section property for these secondary beams. For that, I went to define section properties frame section, and here I added a secondary beam 230 by 300. If you click on this secondary beam 230 by 300 and then click on modify show property, you will see that this is our secondary beam. The material is M25, the depth is 300 mm and width is 230 mm. The modifiers I have used similar to what we used for the primary beams, and then rebar details also I have added here. So here I have defined a secondary beam, and after defining secondary beams, to draw those beams you have to go to define and not define, you have to go to draw beam column brace objects and this quick draw secondary beams. And here select the property first. Our secondary beam is sec beam 230 by 300. The moment releases will be pinned for secondary beams, and then your orientation of the beams can be either parallel to y-axis or parallel to x-axis. For example, here we have number of beams 3, and then the orientation is parallel to y-axis. So if you hover in on any slab, you can see that there are 3 dotted lines here. Since we have selected number of beams 3, there are 3 dotted lines, and these dotted lines are parallel to the y-axis. If you change the orientation to parallel to x, then we will see these horizontal lines here. And if you click on this, in this way you can draw secondary beams. So we don't need these 3. Let me just undo that. And I drew secondary beams on all floors. We drew secondary beams here since the span of our slab is very large. You can see here 5 meter, 6.7 meter, 4.4 meter, and then again 5.65, 5.47, 5.613. So because of these large spans, to control the deflection of those slabs, we are drawing secondary beams here. So after drawing secondary beams, what I did was I defined some pier levels for the shear walls and the basement walls in our building. So let me talk in short about what is pier level or what is spandrel level in ETABS. To define those pier levels, you can go to define and then pier levels and then spandrel levels. If you left click on pier levels, you can just write the name of any wall pier here and then you can do add new name. For example, I have defined up to P23 here. If I want to define a new pier level, I can just type P24 and then add new name, and then this pier level will be added here. So what actually are these pier levels and spandrel levels? So in ETABS, when we are designing shear walls or retaining walls, what the program does is it calculates and reports the required area of steel for flexure and also shear based on the applied and defined load combinations. So during the modeling process, if you remember, we modeled the wall elements as cell elements. And before the program does its task, that means before the program does the analysis, what we should do is, as a designer, we should define the wall levels and assign them as peer or spandrel. Because if we do not assign as peer and spandrel element, the software will understand it is a simple cell element and report the reinforcement and the different types of forces accordingly. But to make the software understand that these are not simple cell elements, rather these are shear walls or basement walls, we have to assign and define wall levels. So the peer and spandrel leveling should perform to get the design forces and reinforcement requirements, and the right leveling should be imposed to ensure realistic output results. So in very simple terms, if you want to understand what is a peer level and what is a spandrel level, you can approximate peer is a column. Peer is equivalent to column, whereas spandrel is equivalent to a beam. That is the most simplest way to understand the difference between peer and spandrel level. So in our model, we do not need to define spandrel levels here. We will only define peer levels. And to assign peer levels, what we will do is, the common method to assign peer level is that if you have these walls in the plan, these adjacent walls in the plan, you have to assign them different peer levels. For example, if you assign this cell element as P1, then you have to give different name to this, either P2 or P3 or any other name, and again P4 or P5 to this cell element. For the walls in the same plan, you cannot assign same peer level. However, if we were to look at the shear wall on this side here, for all these shear walls along this height, from top to bottom, you can assign the same peer level. For example, if you have assigned this cell element as P1, then you can assign all of these cells at the top of this basement wall. You can assign all of these cell elements as P1. So remember, for the adjacent walls, you have to assign different peer levels, whereas for the walls along the height, you can assign the same peer level. So what I did was, I selected these shear walls at first and assigned them one peer level. Similarly, I selected these shear walls at the back here. I assigned these shear walls one peer level, and then again I assigned these shear walls one peer level. And after completing assigning peer levels for these walls along the height, I assigned different peer levels for these basement walls. So let me see what peer levels I have assigned here. For that, go to display. Okay, go to this here, check mark sign here, set display option. And then go to object assignment. Go to cell assignment and then click on this labels and then click on OK at the bottom. Okay, not this. Go to set display option again. I will uncheck this labels here. Go to this tab, other assignment, and in peer assignment, check on this label option and then click on apply. You will see that now the peer levels are being displayed here. So let's go to the elevation view. You can see here that these shear walls at this level, let's look here, all of these shear walls we have assigned the same peer level P6, whereas for these basement walls here, different peer levels have been assigned. For example, this is P6, then this is P8, this is P9, this is P23, this is P22. So how to assign these peer levels? The simplest way to assign is to select any shell element here. Go to assign shell and then peer level, and then select the appropriate peer level from this list and then click on OK. For example, if you want to assign this cell element as P8, select this P8 at the bottom here and then apply and then OK. Similarly, one by one, you can assign peer level to all of our cell elements. So let me delete this and go to our 3D view once again. And finally, before designing the members, what we would like to do is we would like to mesh these shear walls and basement walls. For that, first let me just remove these peer labels here. Go to this set display option again, other assignment tab, and uncheck these labels and then click on OK. And then go to select properties, wall section. I will select this basement wall and shear wall, select and close, and then go to edit cell option and then divide cells. I will use this option, sorry, not divide cells. Go to edit, go to assign cell and wall auto mesh option. So I will use the auto rectangular mesh here and then left click on this mesh settings, and I will choose the approximate mesh sizes 1 meter here, or you can choose a smaller value also, and then click on OK. OK. Now these wall elements have been meshed. Now finally, after completing all of these steps, save your model, and now you can go to the design option. To go to the design option, go to this tab design here. Since ours is a concrete frame design, view revise preference. We are designing our building based on the Indian Concrete Code IS 456, so it's okay. Go to design option again, concrete frame design, and select design combinations. So sometimes what happens is that these design combinations, these will be on your left hand side, and you have to take these combinations, these load combinations, from this left hand side to the right hand side. To do that, you just select or left click on this topmost load combination and then go right through the bottom. In this way, you have selected all of these load combinations. Click on this arrow showing to the right. So these load combinations have been taken to the right now, and then click on OK. And then you can perform design concrete frame design. Okay, this start design check option is not active here because we haven't run the analysis. So first run the analysis. Analysis will take some time because the number of modes to be analyzed we have set to some 60 or 70 in our previous lecture. So the greater the number of modes for which your building have to be analyzed, the greater the time the software takes for the analysis to run. So wait till the analysis portion is complete here. So you can see at the bottom corner here, the model cases are being analyzed here, and it's increasing 49%, 51%. In this way, your building is being analyzed here. And once the analysis is complete, then you can go to the design part. It's almost complete now. So our analysis is complete, and now the software is displaying the displacement of your structure under the influence of dead loads here. You can see at the top displacements dead. Now to perform the design of the structure, you can just click on this concrete frame design, or you can go to this arrow and then click on start design check. The program will design your column, slab, beam elements and the shear wall one by one. Shear wall won't be designed here. First it will design the frame elements only, that is beam and columns. So once the design is complete, let's go to elevation view for any elevation here. For example, I go to this elevation 3. What the software is displaying once the design is complete is that it is displaying the value of the longitudinal reinforcing bar area for our model here. For example, for the column here, 2081 millimeter square area, the software is displaying the value of longitudinal reinforcing bar at one station. Whereas if you see for these beams, the value is being displayed at 6 locations, 3 at the top and 3 at the bottom. So this means it is displaying the value of longitudinal reinforcing bar for 3 sections in a beam, the 2 edges and the middle portion, and that for both top and bottom rebars. Whereas for columns, it is displaying at only one location. So if you want to see the percentage of reinforcement that is coming onto these elements, you can just select on this arrow again, go to display design info, and then go to rebar percentage and then click on apply. Now, instead of the actual value of reinforcing in millimeter square, it is displaying in percentage here. So you can check the percentage of reinforcing bar in our columns and in our beams here, and you can see whether this reinforcing percentage is uh, practically possible or if it is exceeding some designed value. For example, if you look at these columns here, the value of reinforcing bar is 0.80 percentage. So this is the minimum percentage of reinforcement in column according to the Indian Concrete Code, that is IS 456. Similarly, here we have 0.83 percentage, here we have 2.08 percentage, here we have 4.92 percentage. If you look at the codal provision, the maximum percentage of reinforcing bar can be up to 6 percentage for columns. However, as you increase the number of bars or the area of bars in your column, then during the actual construction of these columns in your site, it will be difficult to place the concrete and to compact the concrete because of the huge number of rebar. So you have to try and reduce the value of reinforcement to less than 4 percentage for practical problems or for practicality. Although the code allows the reinforcement percentage to be greater than 4, for practical reasons, you may want to reduce the percentage of reinforcement in your columns. Similarly, if you look at beams, we have the percentage of reinforcement displayed at 6 different locations. So let me just close this and then delete this. Now, how to know that if your beam and column elements have passed under the design loads? The main thing to check after the design is if your elements have passed. And one way or